So in our previous videos, we saw that the data that we collect when we're conducting science may be quantitative, that is, it might be numbers. And these numbers can be either very big, very small, or they could be, modest, somewhere between, say, 0 and 10. But because we are often dealing with very large or very small numbers in science, we've developed this form of notation called scientific notation that helps us write big numbers and small numbers in a very clear manner that is likely not to produce errors. So we're trying to avoid making mistakes. So when you've got a really small number and you have to write out a lot of zeros, it's easy to either misread this number or write this number incorrectly. Similarly, if we have a really big number, the same problem can arise. And if nothing else, it's also kind of tiring writing out numbers in this conventional decimal form. So for these reasons and others, the concept of scientific notation was developed. So decimal numbers become really difficult to use and are prone to error when you're dealing with very large or very small numbers. So typical numbers that we might be using in science would be something like this. This is 6023 followed by like about 20 zeros. That's a pretty standard number of molecules that we might be dealing with in chemistry. Or if we're looking at the size of something like an atom, that will be a decimal point and then 9 or 10 zeros and a 1. And these numbers of these, sizes, these very large numbers and very small numbers are really common in chemistry. So we're going to use scientific notation to help us write these and read these in a manner that is easy and also less prone to errors. So in scientific notation, you're going to write the number in this form. You're going to have a number that's written up the front here, and that number is going to have the characteristic that it has one non-zero number and only ever one, followed by a decimal point, and then a bunch of other numbers. And then that number will be multiplied by some power of 10. So the number that comes out the front there is called the coefficient. And like I said, the quality of the coefficient is it only ever has one non-zero number out the front. And then that's going to be multiplied by a power of 10. And the actual power of the power of 10 is called the exponent. And the whole thing that we're multiplying by is called the exponential term. So here I've written 110,000 meters in scientific notation, but also in decimal notation. And what you can see the difference is here is that I don't have to write out all of these zeros, right? So we've got a coefficient multiplied by an exponential term, and then the actual value that goes in here, this guy here, that's called the exponent. Okay. So what is the exponent? Exponent is a number written in superscript following another number that's called the base, right? So the exponent just indicates how many times a number is multiplied by itself. So when we write 3 to the 5, that just means multiply 3 by itself 5 times. So there we go there. And you should know how to enter these exponential terms into your calculator. For most calculators, what you're going to be doing is you're going to be using what's called the caret symbol, which looks like like a pointy little hat, and that's how you would be entering that. So often we're going to refer to exponents as what we call powers. So we would refer to this as being 3 raised to the 5th power. If we had this, we would say 3 raised to the 4th power. Some powers have special names. So when the power is 2, we call that squaring. And when the power is 3, we call that cubing. So the number out the front there is the base, and then the superscript is the exponent. Okay, so you want to go through and make sure that you know how to do this. So I'm just going to pop my calculator up now, and I'll show you how to enter in these. So here's my calculator, and if I want to enter in 3 to the 6, what I'm going to do is just go 3, and then I'm going to hit the caret button, and 6, followed by enter. Now my calculator is in scientific notation mode because I wanted to demonstrate scientific notation. So there we go, we can give this answer in scientific notation, 7.29 by 10 to the 2. We'll do another one, and just to illustrate the point, I'm going to do the third one on the list there, which is 9 to the power of minus 2. So we go 9 power, and then you want to make sure you know the distinction between your minus button and your subtract button. So my minus button is here, minus 2, and then enter, and we're getting we're getting a longer answer here. Okay, so that's how it works. Just make sure you know how to enter in these kinds of terms into your calculator. All right, so scientific notation is kind of simple because it exclusively uses powers of 10. So we're only ever going to be multiplying our coefficient by a power of 10. So when 10 is raised to a positive power, what the answer that you're going to get is the decimal equivalent followed by as many zeros as the power. So you get 1 for 10 to the 0 followed by 0 zeros. For 10 to the 2, you get a 1 followed by 2 zeros. For 10 to the 3, you get a 1 followed by 3 zeros, and so forth. So powers of 10 are really easy to work with. Now these are positive powers of 10. When 10 is raised to a negative power, you're going to get a number less than 1 every time. And so what is that number that less than 1 going to be? Well, see here we've got 10 to the minus 1. That is equivalent to 1 on 10 to the 1, or 1 on 10, which is 0.1. And perhaps you can kind of see what's going on here. Maybe we need another example. Here's 10 to the minus 2. So that's going to be 1 on 10 squared, or 1 on 100. And there we are. So now maybe you can see the pattern. We've got minus 1 there, and our 1 comes 1 space after the decimal point. We've got minus 2 here, and our 1 comes 2 spaces after the decimal point. So what's going on here? Well, the absolute value of the power is always 1 less than the number of zeros between the decimal point and the 1. So in our 10 to the minus 1 example, we had 0 zeros between the decimal point and the 1. In our 10 to the minus 2 example, we had only 1 zero between the decimal point and the 1. In 10 to the minus 3, we have 2 zeros, then the 1. And in 10 to the minus 4, we have 3 zeros and then the 1. So it's kind of easy to check whether you've got your negative power of 10 correct. Okay, so a single power of 10 is sometimes referred to as an order of magnitude. So a good example of this would be that 10 to the 4 is 1 order of magnitude bigger than 10 to the 3, right? 10 to the minus 2 is 4 orders of magnitude smaller than 10 to the 2, because we've got to go 2, 1, 0, 1, minus 2, all right? So there we are, 1, 2, 3, 4 orders of magnitude. 1,000, another way of writing 1,000 would be 10 to the 3, and that's going to be 1 order of magnitude larger than 100, which is 10 to the 2. 0.001, we've got 3 numbers here to the left of the decimal point. That's going to be 10 to the minus 3, is 1 order of magnitude smaller. This guy here would be 10 to the minus 2. Yep, and we can see that minus 3 is 1 unit smaller than minus 2. So it's kind of, it's not too difficult, all right? Okay, that should have been a minus there. Okay. So you're going to need to learn to be able to convert between scientific notation and regular decimal numbers in both directions. So you have to write two things, right? We always have a coefficient, so with one non-zero number to the left of the decimal point, and then that's going to be multiplied by a power of 10. So what you have to decide is what's my coefficient and what's the size of my power of 10. Okay, so they're the two things you have to decide when you're doing this conversion. So you can always go ahead and write your coefficient, because remember your coefficient only has one non-zero number to the left of the decimal point. So the first thing you're going to do is write your number out again, but you're going to move the decimal point so that you leave just one non-zero to the left of the decimal point. Okay, so that's what we're going to do, right? We're going to make sure that we have a coefficient like that. Now when we're moving the decimal point, we're going to keep track of how many spaces we moved the decimal point. So the next thing we have to do is to decide the size of n. And the absolute value of the power of 10 is always just going to be equal to the number of spaces you had to move your decimal point to get your coefficient, right? So that's easy. So if you moved your decimal point 3 spaces, then n is going to be 3. Now, the next thing is to decide whether you've got a negative or a positive exponent. And how you're going to decide that is really easy. If the number that you started with was less than 1, then your exponent is a negative number. And if the number you started with was greater than 1, then the exponent is a positive number. So it's pretty easy going. So we'll give a couple of examples now. So we got 5015. My first step is to move my decimal point so that I only have one non-zero to the left of the decimal. So I'm going to write my coefficient like this. Okay, now I have to decide the size of my power of 10. Well, this number is a big number, so I know that I'm going to have a positive exponent. And then I have to think, how many spaces did I move my decimal point? 1, 2, 3. So it's going to be positive 3. So it's not too bad. Okay, so my next number, 0.0122, I need to move my decimal point so I have one non-zero number to the left of the decimal. So I'm going to move my decimal point so that the 1 is to the left of the decimal. Then I have to multiply by my power of 10. Now my original number in this case was a number that was less than 1, so I know my power of 10 will be a negative number. The size of my exponent is just equal to the number of spaces that I had to move my decimal point to get my coefficient. So that's 1, 2. So that's just going to be negative 2. All right. So let's do the next one, 0.0016. So it's a small number, so I know it's going to be a negative exponent. So 0.0016, I've got to move my decimal point so I have just one digit to the left of the decimal point. So that's going to be my coefficient. And then I've got to multiply that by my power of 10. Because I'm starting with a number less than 1, it's going to be a negative exponent. And what's the size of the exponent? I had to move my decimal point 1, 2, 3 spaces to get the decimal point in the correct position. So my number in scientific notation will be 1.6 by 10 to the minus 3. Now I'm just going to mention something now which won't have a lot of meaning at the moment. But the coefficient in your number, when you write it in scientific notation, always has the same number of significant figures as the decimal number. So that doesn't mean a lot right now, but you want to keep that on. You want to keep that at the front of your mind later on, when we're dealing with significant figures. And I'll review that at the time, but I'm just mentioning it right now. Okay, one of the things that can be awkward to estimate when you're looking at a number written in scientific notation is what we call the uncertainty. That is like, how well do we know the number? And how well we know the number is can be expressed using this kind of concept of plus or minus notation. And the uncertainty in a number that is written in scientific notation is just plus or minus 1 in the last digit of the coefficient. But you have to remember to multiply your coefficient by the exponential term. So this number here, we know that the uncertainty is going to be plus or minus 0.1 times 10 to the minus 3. That's how well we kind of know this measurement, right? Okay, or another way of writing that is it's going to be plus or minus 10 to the minus 4. You know, you could also write it as plus or minus 0.0001, and I've got all of those forms written out there. But it's kind of tricky to understand the uncertainty for a number written in scientific notation because you've got to remember to multiply by that exponential term. All right, so we'll just do a little few examples of this. So what have we got here? The uncertainty is going to be 0.001 times 10 to the 4, right? Okay, so that's going to be that one there. And if you multiply that out, that ends up being plus or minus 10. In the next one, here's our last digit, 0.1 times 10 to the 5, and if you multiply that out, that would be plus or minus 10 to the 4, or you could say plus or minus 10,000. Okay, is that answer there? All right, and then for C here, there it is there, 0.1, that's our last, times 10 to the minus 1, which would give me plus or minus 10 to the minus 2, or alternatively, plus or minus 0.01. Any of those ways would be appropriate. Okay, so yeah, it's a little tricky to kind of do that, but not impossible. Okay, so that concludes our section on scientific notation. You need to kind of get used to using scientific notation. It's a really important concept in general chemistry.